I'm realizing now how long that title is, but thank you for the introduction. My name is Amanda Hart. I am a PhD student at UMass Dartmouth, and as my very long title suggests, I'm going to be talking about some work I'm doing with the recreational summer flounder fishery. So to start off with a little bit of background, in the U.S., a lot of our fish populations have started to shift northward over time in response to changing climate and habitat conditions. And in this left graph, this is represented by those dark black lines. And if you can see then, there are faint light gray lines that represent the movement of the commercial fisheries that are slowly following the populations of these species northward. And while we're already observing these trends, they're also likely to continue moving forward in time. This right figure shows the historic center of population biomass for 3 different commercial species in an open circle, and then a projection of where that population center of biomass will be 60 to 80 years in the future in those closed circles. So what's particularly interesting to me about these 2 studies is the fact that summer flounder happens to be used as examples in both of them. And one of the reasons for this is because summer flounder are moving northward pretty dramatically, and the commercial fishery is following them. But for this species, the commercial fishery isn't the whole story. Every year, 40% of the acceptable biological catch for summer flounder is set aside for the recreational fishery, which operates mainly in 9 states from Massachusetts down to North Carolina. This means that the recreational fishery is likely to have a very strong impact on the population status and over time for this species, but we don't necessarily have as much information about how this fishery will respond as the population moves. So kind of as a big picture question, my dissertation work is focused on answering some of these questions about how will the recreational fishery respond to these climate-driven movements, and how does that play out in the context of management regulations that are often different and enforced differently across the coastline where this recreational fishery operates. But for the purpose of the talk I'm giving today, I'm going to try to answer a much more narrow question, which provides some very important background context that will help me address these big picture questions later. And in particular today, I want to understand better what type of fishing occurs in the recreational fishery and how that might vary across space and time. And to answer this question, we can start by simply asking fishermen, what do you look for in a recreational fishing trip where you're catching summer flounder? Now, I didn't directly ask that question myself, but in 2010, there was a saltwater recreational fishing survey that asked a little bit more than 3,000 recreational anglers exactly that. If we give you a couple of different trips to pick from, which one would you most like to go fishing for? The survey was conducted from March to December in 4 different geographic regions, and those regions cover the 9 states where summer flounder are typically caught. Each region had 16 versions of the survey, and every survey had 8 questions where 4 different choices were presented to an angler, and they got to pick which of those was most appealing. They were asked to pick between 3 saltwater angling trips, so these are trips A, B, and C, or they could opt out of saltwater fishing altogether. Additionally, anglers didn't necessarily have to answer a question if they didn't want to for whatever reason. So for the purposes of how I'm using this data, I've removed any questions that weren't answered, and I also didn't include surveys where anglers always elected to opt out of saltwater fishing across all 8 of those questions that they answered. So this is what the distribution of those selected trips ended up being. Most people opted to take a saltwater angling trip of some kind, so trips A through C. But there were some people who opted out of saltwater fishing altogether for some portion of the trips that they were asked to select between. But beyond just understanding, do you go saltwater angling or not, it's really important to also understand what information was provided about these trips that led anglers to make these decisions. And to that end, each of the saltwater trips had a series of trip attribute informations, which described what would your fishing trip look like if you took it. And because I'm studying summer flounder, I'm focusing a little bit more on those attributes, which included the bag size and the minimum landing size, which reflect management regulations for the fishery, the number and size of the summer flounder you're expecting to catch if you take the trip, can be connected to those population movements and availability of the fish to anglers. And then there was also information on the number of summer flounder that you keep at the end of the day. This type of attribute information was available from these surveys for an additional 4 saltwater species that you might catch on the same trip. But because I'm less focused on those species, I aggregated that information into a single set of attributes that describe the bag size of all other species, the number of all other fish that you might catch, and the number of those other species that you would keep at the end of the day. Additionally, there was a price associated with each of the saltwater trips that were presented. Digging a little bit more into the specifics of what that looked like, these first 8 boxes show the details of what your trip would look like for trips A in orange and trips B in gray. The main difference between those is that for trips A, the number of fish you might catch was reported as a range, and here I've just summarized it as the median of that range, whereas trips B reported a specific number of fish you were expecting to catch. Trip C is only in this bottom right-hand plot for price, because trip C represented a saltwater trip that you could take, but you wouldn't be fishing specifically for summer flounder or any of those other species. So you still get to go fishing if you pay a specific price, but you're fishing for something else. In general, this information can speak to very broad patterns that maybe you can pick out. For example, the bag size of summer flounder, so how many fish the regulation says you're allowed to keep. Anglers typically ended up selecting trips with slightly higher bag sizes than smaller bag sizes, but it's kind of a big trend. So if we want to use this information to make a stronger statement about how these trip attributes are impacting the choice to take a saltwater trip of a certain type or opt out altogether, we need to take this data one step further. And to do that, I use this information to build a series of utility models. So I fit these multinomial utility models to predict the trip alternative that an angler is expected to take based on the trip attributes. And so I've just selected 3 out of many models that we fit here. But as an example, this first model only includes attribute information on the price and summer flounder specific attributes. We got a lower AIC value, so a better fitting model, if we also included some information about the other species you might catch. But this AIC score increased, and the model didn't fit as well if we included all of the attributes. Digging into some of those model diagnostics a little bit more specifically, we can see that for our best fitting model, we were estimating these covariate parameters for each of the categorical trips that you might take. the standard errors for these were fairly small, as were the p-values. And so this, combined with the lowest AIC score, makes us fairly comfortable that this model is fitting our data pretty well. But if we look at a model that included all of the trip attributes, we see something pretty similar, where we have low standard error and we have these low p-values, but the AIC score was a little bit higher. So for this model, we don't have a horrible fit, but we're probably overfitting to our data a bit by including all of these extra attributes. So all of that's great, but at the end of the day, we really want to know, can this model predict what trip an angler is likely to select as their preferred type of fishing trip? And the answer is yes, it does a pretty good job. I showed you these survey responses on the left a little bit earlier. And here on the right are the predictions that this model is expecting given the attributes of these trips. And generally, it's very similar. There were a little bit more predictions for trip A than for trip B relative to the actual surveys, but the pattern is holding pretty well. So this kind of confirms that our model is doing what we want it to. But there is one more bit of information that we can get from this type of model. And to do that, we can look a little bit more specifically at the actual estimated parameter values for the model. And I'm just going to make a note that we mean center the data, which is why in this plot that I've updated, the price has negative values, but that's just negative relative to the mean price. So if we want to understand how attributes are impacting the probability that you would take one of these saltwater trips, A, B, or C, we need to look at the magnitude of these parameter estimates. By far, the highest value is this intercept. So if any of our trip attributes is going to strongly impact the probability of taking one of these trips, the contribution of that attribute needs to be on par or larger than this intercept. Otherwise, the intercept is really driving that, that estimated probability of taking one of these trips. So at face value, it looks like most of these numbers are pretty small compared to this intercept. But it's important to remember that this is a parameter value that's going to be multiplied by the actual setting for the attribute. And for something like price, for an attribute like price, there's a really wide range of prices. And if you're at the extremes of this range and you multiply that value by this parameter estimate of about 3, all of a sudden, the contribution of price is on par with this intercept, and price is really the only attribute where that's the case. So price is strongly impacting whether you choose to go and take a saltwater fishing trip or whether you opt out of fishing altogether. Whereas in contrast, some of these other parameters, even if the parameter value itself is a little bit larger, even at the extremes of this range, it's not going to have quite as much of an impact as price would on that probability of going fishing. Which just leaves one remaining question. If you end up going saltwater fishing, which trip do you take? And to answer that question, it's useful to look at some of the attributes where the sign of attribute varies across these trips. For example, the bag size of summer flounder. The sign for trips A and B is different, which means that for the same bag size, so the same regulation of summer flounder, trips A and B are going to have a different trend in the probability than trip C. And so that might help distinguish when you choose to take trip C over trip A and B. And similarly, the bag size of other species has this different sign between trips A and B, and that again might help distinguish when you're more likely to take trip A over trip B. as far as the utility models go. But there are a couple of other things that we need to look at before we wrap up this work and say it's definitely done. So as far as next steps, the models I've talked about, we treated each answer to a survey question as an independent point, when in reality, the same respondent answered multiple questions, and it's possible that there's an individual effect because of that correlation. So we need to take another look at this to see how strong of an individual effect there might be in our data and potentially adjust our model to account for that. And finally, to circle back to some of those big picture questions, the utility models that I was focused on today are eventually going to be integrated into a larger management strategy evaluation. So in this schematic, they will fill in the fisherman response piece to describe the realized catch as we run these simulations to test different management procedures. So with that, thank you all for listening, and I'd just like to thank, again, my co-authors and Garrett Piper, who contributed to this work, as well as my funding sources.